Somewhere in this galaxy tonight, someone may be trying to reach us. It is a strange thought to fall asleep to, and yet, by the end of tonight, I think you will find it is one of the most calming thoughts in all of science. Because tonight, we are going to follow that someone, a visitor, from a world we will never name, looking across the dark at a small blue planet they have never seen up close. And we are going to walk beside them, slowly, through every doorway the universe places between their sky and yours. The story begins, as many good ones do, with lunch. In the silent depths of the Pacific, ancient submarine canyons carve the seafloor, hiding ecosystems older than human history. Enrico Fermi was one of them, a man famous among his colleagues for solving enormous problems with a pencil and the back of a napkin. Edward Teller walked with him, and Herbert York, who would later write the story down. The talk that day drifted from newspaper cartoons to flying saucers, and then quietly on to the stars themselves. The subject changed, the meal went on, and then, somewhere between the soup and the coffee, Fermi looked up from his plate, as if continuing a conversation only he had been hearing, and asked the question that has never been fully answered since. Where is everybody? Tonight is our long, unhurried answer. If you enjoy drifting off to slow science like this, you are welcome to press the like button or subscribe quietly so more nights like this can find you, and then let all of that go because there is nothing to do for the next 2 hours but listen and breathe and drift. Here is the answer, whole, at the very start. You may hold it all night, and there is no trick waiting at the end. It is not that they do not exist. The galaxy has had 13 billion years and holds hundreds of billions of suns, and many careful scientists quietly suspect that somebody, somewhere, is looking back. The answer is that between any visitor and your window stand 8 gates. 8 separate doorways, built not from steel, but from distance, from energy, and from time. Only one of them is locked absolutely, sealed by a law of physics that no technology on any world will ever break. Every other gate is merely priced. And the prices stack, one on top of another, gate after gate, until the total becomes something no civilization, however patient, however brilliant, has any sensible way to pay. Effectively impossible, that is the honest phrase. Not forbidden. Just priced beyond the reach of worlds. And if that sounds like a heavy thought, hold it a moment longer, because it folds into something soft. It means the quiet above your roof tonight is not an accident and not a warning. It is simply the sound of 8 closed doors. Before we walk to the first gate, one small picture to carry with you through the night. Sometime this evening, a little of the lamplight from your own window slipped through the glass, through the air, and out past the sky. It has not stopped. It will not stop. Moving at the fastest speed the universe allows, that little shine of yours will still need 4 years and 3 months just to pass the nearest star to our sun. Remember that beam. We will meet it once more at the very end of the night, and finding out where it has gotten to by then may be the gentlest fact you hear all week. So here is the map of the road ahead, the 8 gates, in order, each one waiting behind the last. First, a visitor has to find us, and Earth, as we are about to see, is almost perfectly hidden. Second, they have to choose us out of billions of other worlds, using light that is centuries out of date. Third, they have to cross a distance that turns every human word for far into a joke. Fourth, they have to pay for speed, and the universe keeps a strict price list. Fifth, they have to survive the crossing through a desert that quietly sandblasts everything that moves. Sixth, they have to stop at the far end, which, strangely, costs as much as going. Seventh, they have to arrive in the right century, in a universe where time itself refuses to hold still. And eighth, if they somehow stand at the final doorway, they have to touch a living world without harming it, or themselves. 8 gates. We will take them one at a time, the way you might walk a long hallway at night, trailing one hand along the wall. Nothing here will startle you. There are no monsters in this story, no invasions, nothing waiting in the dark. Just physics, patient, impartial, and strangely kind, asking every traveler in the galaxy the same quiet questions it asks us. And each time we finish a gate, I will say the same small sentence, so your mind can set the chapter down like a stone placed on a path. One more gate stays closed, and the sky above you stays quiet. Take one slow breath. Let your shoulders sink a little deeper into the bed, and let us walk together to the first gate, the simple, surprising problem of being noticed at all. Before anyone can visit, they have to know you are home. That sounds almost too obvious to say out loud. And yet, here is the first surprise of the night. Earth, this loud, bright, crowded world, is, from almost every seat in the galaxy, and for almost all of its history, invisible. Start with our voices. Radio is the farthest reaching thing humanity has ever made, and it is younger than some trees. Heinrich Hertz first coaxed radio waves across a laboratory bench in the 1880s, a spark on one table answering a spark on another. Guglielmo Marconi threw them across the whole Atlantic in 1901, from Cornwall to Newfoundland. 3 faint dots of Morse code that made the world feel suddenly small. That is the true beginning of our loudness. Every broadcast since, every song, every news bulletin, every voice down every wire that ever leaked into the air has been swelling outward from Earth at the speed of light ever since, a bubble of faint murmurs growing 1 light-year wider every year. Tonight, that bubble is only about 130 light-years deep. It sounds enormous. Hold it against the galaxy, and it nearly vanishes. The Milky Way is a disk 100,000 light-years across, holding a few 100 billion stars. Our bubble of radio, everything humanity has ever said out loud, in all of history, has washed over only a few tens of thousands of those stars. Roughly 1 star in every 10 million. From everywhere else, from more than 99.9999% of the galaxy, Earth has simply never made a sound, not a whisper. As far as almost the entire universe is concerned, we have not spoken yet, And even inside the bubble, the voices fade fast. Radio obeys a gentle, relentless rule called the inverse square law. Move twice as far from the source, and the signal falls to a quarter of its strength. Move 10 times as far, and it falls to 100th. By the time our earliest broadcasts have crossed even a few dozen light years, they are thinner than a whisper in a stadium, sliding down beneath the natural crackle and hum of the stars themselves. A visitor, hoping to catch one syllable of us, would need an antenna the size of a city, aimed at exactly the right dot in their sky, on exactly the right afternoon of exactly the right century. The universe does not forbid it. It just buries the invitation. So set the signals aside and ask the simpler question, could they just see us? Here, the numbers turn gentle and strange. From 100 light years away, our sun, the blazing center of every day you have ever lived, is one modest yellow point among millions of similar points. A G-type star, a steady, unremarkable kind of lamp, with many millions of siblings scattered through the galaxy's disk. And Earth itself? This whole blue world, every ocean, every mountain range, every city that has ever burned its lights all night, sits so close beside that lamp that it disappears into the glare, 10 billion times fainter than the star it circles. Looking for Earth from another star is like looking across an ocean for a single moth, resting on the glass of a lit lighthouse. To find it at all, a visitor would need the same patient tricks our own astronomers have only just invented. Frank Drake's generation dreamed them. The Kepler mission flew them, a small telescope that stared, unblinking, at one patch of sky for years on end, catching the almost impossibly small wink as a distant planet slid across the face of its star. 4 years of staring for winks that dim a star by 1 part in 10,000. And the James Webb Space Telescope has begun the next trick, reading the thin ring of starlight that filters through a far planet's atmosphere on its way to us, looking for the fingerprints of gases that should not be there. Because Earth does have one honest beacon, and it is not our doing. For about 2.5 billion years, ever since tiny green living things filled the seas and slowly flooded the air with oxygen, our planet's atmosphere has carried a chemical signature that sufficiently patient, sufficiently brilliant instruments could read from light years away. But notice, as you settle deeper into your pillow, what that beacon actually says. It does not say people. It does not say cities, or music, or radio, or anyone waiting up late to be visited. It says only this: something here is breathing. A quiet green whisper, hanging on one faint dot among hundreds of billions of dots, waiting for someone, somewhere, to point exactly the right telescope at exactly the right point of light, and to care about what they find. That is the first doorway, and notice, no one has moved a single mile yet. Before every voyage, before every engine even turns over, you must first be found. And the universe has wrapped our little world tenderly and completely in silence and glare. One more gate stays closed, and the sky above you stays quiet. But suppose the miracle happens. Somewhere out in that field of hundreds of billions of stars, on a world circling one ordinary lamp, an astronomer, or something that fills the role of one, catches the green whisper in our air. Their instruments settle on our dot. Their records open a new page. Now they stand before the second gate, and it is stranger than the first. Everything they can learn about us is old news. Everything. The universe has no live broadcasts. It only has mail. Light is the fastest messenger there is, and even light takes years, centuries, millennia to cross between stars. Which means every telescope, everywhere, is a time machine that only looks backward. If our visitor's world sits 1,000 light years away, still our corner of the galaxy, still by the map we drew at the start, practically local, then the Earth they are studying tonight is not tonight's Earth at all. It is the Earth of 1,000 years ago. They are looking at the year 1026. Let that picture form slowly, because it is a lovely one. The light arriving in their instruments left this planet in a world of ox carts and sailcloth, of candle flame and temple bells and handwritten books. It shows no radio, because there was none. No electric glow on the night side, because there was none. No satellites, no cities of glass, no hint in any color of light that a technological species lives here, because, in the light they have, none did. Carl Sagan liked to say that astronomy is a humbling profession, and this is one of its gentlest jokes. A civilization could study our planet with perfect instruments and perfect patience for their whole working lifetime, and conclude, correctly from their data, that nothing here has ever built so much as a lantern. So what would actually sit in their files, on the page marked with our sun's catalog number? Something like this. A small rocky world, third from its star, warm enough for liquid water. An atmosphere holding oxygen, a lot of it, a fifth of the air, and beside it, a trace of methane. And that pairing would make their instruments pause, because oxygen and methane are a restless couple. Left alone, they destroy each other within decades. For both to remain in one sky, something on the surface must be endlessly, tirelessly refilling both. That is the strongest kind of biosignature science knows, the very signature our own James Webb and its successors now hunt for in the skies of other worlds. It would make Earth interesting. Genuinely, deeply interesting. But interesting the way a tide pool is interesting. A place where chemistry has come alive, not a place where anyone is home. A lit ocean, not a lit window. And our own young instruments have already begun filling that book of worlds. In 2017, astronomers finished a remarkable census around a single small star called TRAPPIST-1, just 40 light-years away. 7 rocky planets. 7. 3 of them orbiting at distances where water could stay liquid. The count began with one small telescope and was completed by NASA's Spitzer Space Telescope and observatories on 3 continents. 1 modest star, 7 candidate tide pools, mapped within a single working decade. Multiply that by the hundreds of billions of stars in the galaxy, and you begin to feel the true size of the visitor's reading list. Year by year, our catalogs of confirmed worlds grow by the hundreds, some years by the thousands, and every new entry is a rival page, another dot, another faint promise, another maybe. Abundance, it turns out, is its own kind of hiding place. The best camouflage Earth ever wore is that the galaxy is crowded with worlds that look, from far away, very much like it. And here is the quiet heart of Gate 2. Their sky is full of tide pools. Everything we have learned since Kepler points one direction, planets outnumber stars, that much is measured. How many of them are truly warm, wet, and welcoming is a different question, and an open one. The cautious statistical tallies suggest hundreds of millions of worlds roughly Earth size, sitting roughly where water could stay liquid. Whether more than a handful of those are actually alive, nobody on any world yet knows. The promising dots may be everywhere, while the confirmed gardens, so far, number exactly one. So our visitor is not choosing between Earth and nothing. They are choosing between Earth and a billion other maybes, and many of those maybes are closer to them, or stranger, or greener, by whatever measures their instruments prefer. In the catalog their sky honestly offers, we are not the cover story. We are page 400, a modest entry, between two other modest entries, in a book of worlds that never ends. To cross the ocean of stars for this world, out of all of them, they would need a reason strong enough to bet centuries on. And all our sky has ever shown them, all it can have shown them, is a whisper of oxygen, 1,000 years out of date. A letter from a world that, as far as they can read, has not yet learned to write back. Let us be fair to our visitor, though. More than fair, let us be generous. Suppose their catalog does flag Earth. Suppose that green whisper of ours climbs, page by page, out of the long book of worlds and lands on some patient desk, on a world we cannot imagine, in front of whatever passes there for a committee. And suppose they ask the question that every civilization, everywhere, must ask before every voyage, the question our own space agencies ask before every launch. Is it worth going? Because the second gate has a second lock, and this one is not made of physics at all. It is made of arithmetic. Plain, patient, unromantic arithmetic. Ask first what a voyage across the stars could possibly be for. Raw materials? Look around their home system, any home system. Every star drags with it a cloud of asteroids and comets, mountains of iron and nickel drifting free for the taking, oceans of water locked up as clean ice, more building stone than any species could use in 1,000,000 years. And all of it, a short, cheap sail from home, with no deep gravity well to climb out of, and no living world to disturb. The ordinary stuff of Earth's crust is ordinary everywhere in this universe. Iron is iron everywhere. Water is one of the most common molecules in the cosmos. Whatever we are standing on, they are standing on too. Energy, then? It pours, free of charge, out of their own star, every second of every era, just as sunlight pours, mostly unused, onto every roof on Earth. A civilization capable of even contemplating starflight has long since learned to drink from that fountain. No one crosses an ocean to fetch water. Territory? Between the habitats they could build at home, from all that free stone and free light, and the billion nearer tide pools in the catalog, Earth is a very long walk for a very ordinary field. Which leaves knowledge, and here, at last, the ledger shows something real. Knowledge is the one cargo that truly is different on every world. What does a living planet taste like? What shapes has evolution tried 400 light years from home? What songs does chemistry sing elsewhere? That hunger is genuine. It is the same hunger that built every telescope on this planet. But notice, and this is the pivot of the whole gate, knowledge is precisely the cargo you do not need a crewed ship for. John von Neumann showed on paper, back in the 1940s, before the first satellite ever flew, that self-reproducing machines are possible in principle, and later thinkers carried the idea out to the stars, probes that could observe, analyze, report, perhaps one day even copy themselves from local stone. Arthur C. Clarke spent a joyful career imagining the consequences. A robotic probe does not eat. It does not sleep, does not fear, does not miss its family, and does not need a ticket home. It can weigh 1,000 times less than a vessel that must keep warm bodies alive. And as we will see at Gate 4, in the economics of starflight, mass is everything. For the cost of one crewed voyage, a civilization could scatter whole, quiet fleets of probes, that is the honest shape of the exchange, on their world exactly as on ours. Every line of the ledger points the same way. If curiosity ever does cross the deep sky, it will almost certainly cross it as a small, silent, sterile machine, not a ship full of travelers. In the silent depths of the Pacific, ancient submarine canyons carve the seafloor, hiding ecosystems older than human history. Our own species has already run this exact calculation, in miniature, and you know how it came out. When humanity wanted to see Pluto, we did not send a crew. We sent New Horizons, a machine the size of a piano, and it flew 9 years and 3 billion miles and answered every question we asked of it. When we wanted a handful of asteroid dust, we sent a robotic hand to fetch it. The pattern is not timidity, it is arithmetic, and arithmetic reads the same in every sky. And for the visitor, there is one more line in the ledger, the quietest one, time itself. A probe strips the voyage of biology. No food, no fear, no grief, though not, as we will see at the fifth gate, of wear or failure or forgetting. A crew keeps all of it. Whatever a living traveler is worth, the ocean charges them interest the whole way across. Food, warmth, air, patience, while a machine, at least, travels light. Carl Sagan once called the shore of the cosmic ocean the place where we have waded ankle deep for all of history. It is a lovely image, and here is its quiet completion. Every other civilization stands on its own beach, doing its own arithmetic, feeling the same cold water. The tide comes in slowly, everywhere. One more gate stays closed, and the sky above you stays quiet. Now we come to the gate that all the other gates lean on, the oldest wall in the universe and the softest. Forget finding us. Forget choosing us. Let the visitor simply try to come. Between their doorstep and ours lies the third gate, distance, of a kind that no living mind, theirs or ours, was ever built to feel. Start as close as the universe will allow. The nearest star to our sun is a small, faint red lamp called Proxima Centauri. It was found in 1915 by a quiet Scottish astronomer named Robert Innes, working through the southern nights at an observatory in Johannesburg, comparing photographs of the sky plate by plate until one faint point gave itself away. Proxima sits 4.24 light-years from your pillow. Said quickly, that sounds almost neighborly. 4 and a bit of anything sounds like a short trip. So let us unfold it once, slowly, the way you might unfold a map on a table. Light, the absolute fastest thing there is, the speed your lamplight left at tonight, crossing from Proxima to here, without pausing, needs 4 years and 3 months. In miles, that same little gap is about 25 trillion. And 25 trillion is not really a number to a human mind. It is a wall of zeros. So do not picture it. Count it. Imagine counting one number every second, without pause, never sleeping, never eating, never resting your voice. You would pass 1 million after 11.5 days of ceaseless counting. You would pass 1 billion after 32 years. A whole working lifetime spent counting gets you 1 billion. And to reach 25 trillion, you would count for roughly 790,000 years. Almost 800,000 years, 1 second at a time. Several times longer than our entire species has existed. That is the distance to the very nearest star. Not a far one. Not a special one. The nearest. Or leave the numbers aside and try the road with anything you know. A passenger jet, cruising the way jets cruise, would need about 5 million years to reach Proxima. A rifle bullet, never slowing, well over 1 million. Even the solar wind, the fastest breath our own star exhales, would drift for thousands of years before it wandered so far. Choose any pace from the entire catalog of human motion, and the answer keeps coming back in geological time, in ice age time, in time deep enough that continents shuffle their positions while you travel. The gap between stars is not large the way a sea is large. It is large the way history is large, and out here, history is only ever getting started. Now set something real on that road, the realest thing we have. In 1977, humanity launched Voyager 1, and bolted to its side rode a golden record of greetings and music, prepared for the flight by a committee Carl Sagan led, just in case anyone ever should find it. Nearly 50 years later, Voyager 1 is still, after everything, one of the fastest objects human beings have ever thrown. It has been falling outward through the dark ever since, at about 17 kilometers every second. 17 kilometers every second, from your bed to the horizon in a heartbeat, Earth to the moon in 6 hours. It is the farthest traveled machine in human history. And in half a century of ceaseless, flawless flight, it has covered less than 1 single light day, not a light year. A light day, the road to Proxima holds 1,500 of those days, and Voyager, had it been aimed there, it was not, would need roughly 75,000 years to drift the distance. 75,000 years ago, no human being had yet planted a field, tamed a horse, or written a word. And here is the detail to carry into sleep. When it finally arrived, it would not stop. It would simply keep going, straight through, silent past the harbor and out the other side, because stopping, as we will learn at the sixth gate, is a doorway all its own. This is what the third gate teaches, and it never once raises its voice. Between every star and every other star lies an ocean with no islands, no harbors, no wind, and no far shore that ever seems to come closer. Every civilization in the galaxy, whatever it builds, whatever it dreams, wakes up on the beach of that same ocean, listening to the same enormous quiet. And Proxima, remember, is only the front step. The true size of the neighborhood is the next thing our visitor must swallow, so let us climb the ladder gently, rung by rung. Within about a dozen light years of your bed sit only a couple of dozen star systems, small change in galactic terms. After the Centauri family, the next stop is Barnard's star, the faint red dwarf whose extraordinary crawl across the sky was measured in 1916 by Edward Emerson Barnard, a man who had begun his working life as a photographer's assistant in Tennessee and ended it as the sharpest-eyed observer of his age. Faint, quiet, 6 light years out, half again as far as Proxima. And the clock of the Great Drift is worth holding for a moment, because it quietly reframes every calendar you know. Our sun, hauling its whole small family of planets, and you with them, takes about 230 million years to complete one lap around the galaxy. One galactic year. The last time we passed the place we occupy tonight, the dinosaurs were young and the Atlantic Ocean had not yet opened. Every star the visitor might chart is partway through its own vast lap, on its own tilted track, and the lanes do not stay parallel. Over the spans a starship actually needs, the entire sky rearranges itself, like furniture moved slowly in a dark room. Navigation between stars is not geometry. It is choreography, danced in the dark, across thousands of years, with partners who never stop moving and cannot hear the music. To gather even a few thousand stars around you, you must draw your circle 100 light years wide, 25 times the gap that just cost us nearly 800,000 years of counting. Push the circle out to 1,000 light years, and you enclose millions of stars. That is the distance where the light arriving tonight left during the age of candles. And still the galaxy keeps going. 100,000 light years rim to rim, a disk so wide that light itself, our fastest thing, spends 1,000 human lifetimes crossing it. If the visitor's world lies even a modest way into that map, every difficulty we have priced so far multiplies by hundreds. But the third gate holds one more turn of the key, and it is the one almost nobody thinks of, lying awake or otherwise. The map itself will not hold still. Stars do not hang in the sky like nails driven into a wall. Every one of them is falling along its own long path around the galaxy's center, our sun included, carrying you your bed, and everything you have ever known around that far hub at more than 200 kilometers a second. Each star moves at its own pace, on its own heading. The constellations outside your window tonight did not exist when the first cave painters looked up. Give the sky another 100,000 years, and they will have quietly dissolved again, like breath on glass. Even our nearest neighbor will not wait for us. Proxima Centauri is, right now, drifting closer. It will make its nearest approach in roughly 27,000 years, and then begin, forever after, to pull away, as if even the closest door in the neighborhood were slowly swinging on its hinge. The European Space Agency's Gaia mission spent a decade measuring precisely this, the positions and drifts of nearly 2 billion stars, the finest map of anything humanity has ever drawn. And what the map proves is the deep truth of Gate 3. To sail to a star, you cannot aim at where it is. You must aim at where it will be, centuries or millennia from now, and hold that aim across a dark, with precious few nearby landmarks and no second chances at all. A voyage of 1,000 years, pointed at a target that moves, launched from a platform that is also moving, with an error budget of nearly nothing. Let the aim drift by 1/100th of 1 degree at launch, and by the far shore, you have missed by billions of kilometers, nearly the width of the entire planetary system. An ocean with no shore, crossed toward a lighthouse that is sailing too. That is the third gate. And no engine, however mighty, makes the ocean 1 mile smaller. All an engine can ever do is try to pay for speed. Which brings us, after a slow breath, after the ambient dark that follows this chapter, to the price list itself. One more gate stays closed, and the sky above you stays quiet. In the late 1890s, in a log schoolhouse in provincial Russia, a nearly deaf mathematics teacher named Konstantin Tsiolkovsky sat down after lessons with a pencil and worked out, publishing it to the world in 1903, the single most important equation in the history of travel. He had taught himself science in a library, 3 years of borrowed books, because illness had taken his hearing and closed the schools to him. He was asking a question that sounds like a child's. How much fuel does a rocket need? The answer he found, we call it the rocket equation now, and it has governed every launch from his notebook to this morning, is one of those truths that starts small and quietly swallows the world. It says this: a rocket must carry the fuel to push its cargo. Fair enough. But it must also carry the fuel to push that fuel, because the fuel is heavy too, and then more fuel to push that fuel, and so on, down and down, a spiral with no natural bottom. Want to go a little faster? You need not a little more fuel, but noticeably more. Want to go much faster? The requirement stops being a slope and becomes a wall. The mathematics is exponential, which is arithmetic's polite way of saying it runs away from you. Robert Goddard, the shy American professor who flew the world's first liquid-fueled rocket out of a snowy Massachusetts cabbage field in 1926, spent his whole life climbing the gentle lower slopes of Tsiolkovsky's curve, Starflight does not live on the slopes. Starflight lives on the cliffs. To feel the height of the wall, you do not need the algebra. One honest example will do. With the finest chemical rockets ever flown, the kind that carried astronauts to the moon, reaching even 1% of light speed would demand more fuel than there is matter in the visible universe. Read that once more, slowly. Not more fuel than a nation could refine, or a planet could mine. More than existence contains. The exponential is not exaggerating. That is simply what exponentials do, past a certain line. So the dream of starflight begins by abandoning chemistry altogether and reaching for fiercer fires. Let us see what even the fiercer fires cost. So let us price a single honest example and price it slowly, because this number is the heart of the fourth gate. No crew, no cargo bay, no gardens, no passengers. Just one modest robotic ship, the mass of a small family car, 1,000 kilograms, pushed to 1/10 of the speed of light, the ambitious benchmark most serious starflight studies reach for, if the world that launched you is to still remember your name when you arrive. The kinetic energy alone, set aside the engine, set aside every inefficiency, count only the pure motion, comes to about 4.5 times 10 to the 17th joules. Numbers that size need a household to live in, so give it one. Picture a large power station, a full gigawatt, the kind whose cooling towers you can see from a highway, the kind that lights 1,000,000 homes. Now take every home off the grid. Every lamp, every kettle, every refrigerator, all of it, redirected into pushing one small car-sized machine through the dark. At that pace, the station pays the bill in about 14 years. 14 years of 1,000,000 households' entire electrical life for one small probe at the minimum serious speed, one way. And the equation is not finished, because kinetic energy grows with the square of speed. Double the speed, and the bill does not double, it quadruples. Above all of this, above every engine and every budget, stands the one lock in tonight's entire story that is truly, permanently absolute. Albert Einstein. In 1905, a young patent clerk writing in the evenings showed that the speed of light is not a record waiting to be broken. It is a property of space and time themselves, part of the grammar of the universe. As anything with mass approaches that speed, the energy required to push it faster swells without limit toward infinity. And infinity is not a large budget. It is not a budget at all. This is the single rule the universe enforces without exception, without appeal, and without wear. Nothing that has mass reaches light speed. Not us. Not the visitor. Not anyone, ever. Every other barrier tonight is a price tag, and price tags can at least be read. This one is a law. So the visitor cannot outrun the ocean. The only question left standing at this gate is whether anyone, anywhere, can afford even the lawful speeds. Let us walk the aisles and read the shelves. Walk the aisles of the possible engines with me, the real ones, the ones physics genuinely permits, and read the prices as we pass. There are 3 shelves, and each is a little more beautiful and a little more expensive than the last. First shelf, fusion. The fire of the stars themselves, hydrogen pressed into helium so hard it gives up light. It is utterly real. The sun above your roof has run on it since before Earth had oceans, and it has never once missed a morning. We have chased a tame, controlled version since the 1950s, and the joke among plasma physicists has grown gray along with the field. Fusion is 30 years away, and always will be. The Great International ITER project in the south of France, a reactor the size of a cathedral, 35 nations, decades in the building, exists to prove, for the first time, that a caged star can pour out far more energy than it swallows. One demonstration, on the ground, with the resources of half the world behind it. A fusion starship must tame that same fire, steadily, or pulse after patient pulse, for year upon year, inside a machine light enough to fly. The shelf is real. It is also very, very high. Second shelf, antimatter, the perfect fuel, matter's mirror twin. Bring it together with ordinary matter and both vanish utterly, everything converted to pure energy. Einstein's famous equation, paid in full, nothing held back. A single gram of it, meeting a gram of ordinary matter, would release as much energy as a small city uses in a year. 1 gram, and now the storeroom. Count every particle of antimatter that every accelerator on Earth has ever produced. CERN, Fermi Lab, all of them. Every experiment across every decade of particle physics. And the grand total comes to less than 1/1,000,000th of a single gram. And it can touch nothing without vanishing, so it must be kept in magnetic bottles, untouched and untouchable. Our finest traps have now held their tiny clouds of antiparticles for months on end, a world record measured in billionths of a gram. The physicist Robert Forward, who took these dreams more seriously and more rigorously than anyone of his century, did the honest bookkeeping, gram for gram, the most expensive substance that has ever existed, anywhere by a margin that makes gold look like gravel. Third shelf, and the cleverest of all, leave the engine at home. In 2016, the investor Yuri Milner, with Stephen Hawking beside him, announced Breakthrough Starshot. Build a vast array of lasers on the ground and use the beam itself to push featherweight sails toward the Centauri stars at 1/5 of the speed of light. No fuel aboard at all, the spiral of Tsiolkovsky's equation, sidestepped entirely. The physics genuinely checks out. That is what makes the label on this shelf so instructive. Read it slowly. The laser array must fire with roughly 100 gigawatts, the combined output of 100 large power stations, all lit at once, held in perfect focus. And the payload that Price can push to 1/5 of light speed is approximately 1 gram, a paperclip. The engineering of an entire planet, straining in unison, to throw a paperclip at the nearest star. A paperclip which, arriving 20 years later, has no way whatsoever to slow down, and crosses the entire destination system in hours, snapping photographs as the harbor blurs past. There is one more shelf, half forgotten, at the back of the shop, and it deserves its minute. In the late 1950s, the physicists Freeman Dyson and Ted Taylor led Project Orion, a completely serious American study of a ship pushed by nuclear explosions, hundreds of them, released one by one behind a great steel plate, each blast a shove. The mathematics worked. The engineering, remarkably, mostly worked. Orion could, on paper, have reached perhaps 3% of light speed, a 140-year voyage to Proxima, at the price of lofting thousands of warheads and letting them off like a slow drumbeat all the way up the sky. The treaty banning nuclear explosions in space, signed in 1963, helped make the project untenable, and it quietly faded, and even Dyson, who loved it best, confessed a kind of relief. Some prices, it turns out, are written in more than jewels. Do you see the shape standing quietly behind all these shelves? The universe keeps a price list, and it never negotiates. Cleverness can find better ways to pay. It has, and it will. But no cleverness talks the number down, because the number is not a market price. It is written into what energy and mass are. A civilization 1,000,000 years older than ours walks these same aisles. Their engineers are incomparably better. Their price list is identical. One more gate stays closed, and the sky above you stays quiet. Suppose, then, that the bill is somehow paid. Somewhere in the galaxy, a civilization richer and more patient than any we can picture has poured a city's whole lifetime of power into one armored hull, and the hull is moving. 1/10 of the speed of light. The ocean of Gate 3, at long last, is sliding by. Now comes the gate that no one ever puts in the movies, because it is invisible. The ocean is not quite empty. And at these speeds, emptiness itself grows teeth. The space between the stars has a name, the interstellar medium, and by every earthly standard, it is the finest vacuum in existence. Picture a sugar cube of space, 1 cubic centimeter, held up anywhere along the road to Proxima. Inside it drifts, on average, 1 single atom, usually hydrogen, the universe's simplest thing, minding its own business in the cold. 1 atom, alone in the cube. For comparison, the sugar cube of air in front of your face right now holds about 25 quintillion molecules, a 2.5 followed by 19 zeros. Deep space is far emptier than any ordinary vacuum chamber on Earth. Only the most exquisite particle traps our laboratories have ever built can manage a cleaner nothing. Our 2 Voyagers have coasted through it for nearly 50 years, and it has never laid a finger on them. But speed changes what things are. That is almost the motto of tonight's whole story. At 1/10 of the speed of light, our visitor's ship sweeps up the road beneath it at 30,000 kilometers every second. Every second, it plows through 30,000 kilometers worth of those lonely sugar cubes, and every atom inside them arrives no longer as a drifting mote, but as a bullet. At that closing speed, a single hydrogen atom lands, with the sting of hard particle radiation, the kind reactor engineers build thick walls against. 1 atom is nothing, but they come by the trillions, second after second, year after year, striking the same bow of the same hull forever. The front of the ship spends its whole voyage inside a slow, invisible sandblaster. Metal fatigues, atom by atom. Electronics sicken in ways engineers can only partly shield. The desert never sleeps, never hurries, and never stops. And the atoms are only the fine grit. Scattered thinly through the dark are true dust grains, tiny solid flecks, the ash of old stars. Here the arithmetic turns vivid enough to feel. A single unusually large grain, 1 milligram, a rare giant by interstellar standards, a speck you still could not feel landing on your fingertip, meeting the ship at 1/10 of light speed, delivers the energy of roughly 100 kilograms of TNT. Read that again, gently. A speck of dust becomes a bomb. Not through malice, through nothing but arithmetic, the same square of speed rule from Gate 4, now running in reverse, against the traveler. And the road to even the nearest star makes no promises at all about dust. So the visitor does the only thing possible: armor. Thick sacrificial plates at the bow, meters deep, designed to be eaten away, impact by impact, across the years. A shield the ship slowly spends, like a candle burning. But armor is mass. And mass, as Tsiolkovsky's spiral whispered 2 chapters ago, must be paid for in fuel, and the fuel in more fuel. And the price list opens again, its numbers climbing. Our own fastest machine, NASA's Parker Solar Probe, hides behind a shield to survive a few hours of fury near our own star, then swings away to cool. This ship's shield can never swing away. It must be held up into the sand-blasting dark for decades or centuries against a universe that is never tired. Engineers who have studied this in earnest have never pretended otherwise. In the 1970s, the British Interplanetary Society ran the numbers for Daedalus, the most detailed starship design of the 20th century, and settled on a wide disk of beryllium at the bow, thin as a plate, yet tons of metal across its whole span, accepting from the outset that the desert would plane it away, kilogram by kilogram, across the decades of flight. Their probe was to be assembled in orbit and fueled from the clouds of Jupiter, and even then, even on paper, it was a flyby design, half a century of falling through the dark, for 12 hours of science at the far end, with no possibility of stopping. That was the honest shape of the best starship humanity ever drew, a mountain of shielding and fuel, wrapped around a heart the size of a living room, sprinting past its destination in a single afternoon. And the hull, remember, is the strong part of the ship. Inside it, ride the parts that break. Every machine you have ever owned has already told you the truth about this gate, quietly, in its own time. Things wear out. Seals dry and crack. Lubricants thicken and creep. Bearings develop a whisper, then a wobble. Electronics, struck by one stray particle too many, forget one small thing, and then, in cascade, everything. Nothing about a starship repeals this. A starship simply asks the question at a scale no engineer has ever faced. Engineers measure honesty and reliability numbers, So let us borrow their arithmetic for one gentle minute, because it may be the most sobering gentle number of the night. Imagine a ship so well built that in any given year it has a 99.9% chance of running perfectly. One failure chance in 1,000 per year. No machine humanity has ever launched comes close to that, granted anyway. Now ask this near-perfect ship to survive a 10,000-year crossing, the honest travel time for 1,000 light years at the speeds Gate 4 could almost imagine paying for. Multiply that tiny yearly risk, patiently, across 10,000 years, and the arithmetic answers without emotion. It is only a back-of-the-envelope model, and real engineers fight back, with redundancy and repair. But its shape is honest. The odds of arriving intact collapse to about one chance in 22,000. Near perfection, sustained for 100 centuries, still adds up to almost certain failure. The dark does not need to break the ship. It only needs to wait. For scale, the oldest machine on Earth still doing its original job is a clock in Salisbury Cathedral in England, built around 1386, one of the oldest surviving working machines anywhere, carried across 6 centuries by generations of human hands that cleaned it, mended it, and more than once brought it back from silence. The visitor's ship must outlast 15 Salisbury clocks, laid end to end, alone in the dark, with no hands to tend it at all. There is a foundation in Texas, the Long Now Foundation, building a clock inside a mountain designed to tick for 10,000 years, and its engineers call it one of the hardest design problems ever attempted. And their clock only has to sit still. And machinery is only half the watch. The other half is memory. Across 10,000 years, the ship must not merely run, it must remember why it is running. Plans must stay readable. Instruments must stay understood. Whatever stands watch at the far end, mind or machine, must still recognize the mission when the moment finally comes. Consider how quickly our own understanding evaporates. We struggle today to read magnetic tapes recorded in the 1970s, and the engineers who truly knew the mighty moon rockets of Apollo have retired, carrying whole libraries of unwritten know-how away with them. 10,000 years is 1,000 times deeper than that. A starship is not only a machine asked to last, it is an unbroken chain of understanding, asked to pass hand to hand through 10,000 winters without one dropped link. And if the visitor is not a machine but a crew, the watch grows longer and softer and sadder. Cosmic radiation seeps through any practical shielding, year upon year. A slow rain no umbrella fully stops. Bodies shaped by a world's gravity gently loosen without it, bones thinning, hearts easing off, as our own astronauts learn in mere months aboard the space station. And on any crossing longer than a lifetime, there is the tenderest problem of all. The ones who arrive are not the ones who chose to leave. Children born mid-ocean inherit a voyage the way one inherits a name, a destination chosen by great-grandparents for reasons written in a language slowly going quaint. Our species has run exactly one small rehearsal of a sealed world, Biosphere 2, a cathedral of glass in the Arizona desert, sealed in 1991 with 8 volunteers inside, every resource lovingly prepared, and the whole of Earth 1 inch away through the pane. Its closed garden, air, food, chemistry, drifted out of balance within 2 years. 2 years, with help just outside the glass. A generation ship is Biosphere 2 asked to hold its breath for 100 generations, with nothing outside the glass at all. None of this says never. It says, once more, what every gate says, this is the cost. A machine that must not blink for 100 centuries, or a village that must stay whole for 100 generations, priced in the same patient currency as everything else tonight. One more gate stays closed, and the sky above you stays quiet. Here is the gate that hides in plain sight, the one even careful dreamers skip past, and the one that, once you see it, you never unsee. Suppose the crossing succeeds. The armored bow has held. The tireless machines have kept their 10,000-year watch. And ahead, at long last, a yellow star swells from a point into a sun, and one small blue world turns beside it, exactly where the 1,000-year-old maps promised. Now the visitor must do the one thing the ocean never, ever helps with. Stop. Space offers almost nothing to brake against. There is no water to drag at the hull, no air to lean back on, no gravel to skid across, nothing out there thick enough to slow a moving ship by more than a whisper. Whatever speed a ship buys at the start of its voyage, it keeps, all of it, every meter per second, held in perfect trust across the centuries, until the ship spends an equal fortune taking that speed away again. Think about what that means for our arriving visitor. A ship that reaches our solar system at 1/10 of light speed and does nothing does not arrive. It passes. It threads the entire system, the comets, the planets, the small blue destination, in less than 2 days, and is gone out the far side into the dark, its harbor shrinking behind it like a lit window seen from a night train that does not stop in this town. To stay, to circle, to orbit, to visit in any meaning of the word, the ship must shed every single meter per second it so dearly purchased. And if it must brake with its own engines, and for most designs, there is no other way, then the rocket equation, you will remember, has no interest in direction. Slowing down costs just as dearly as speeding up did. The price list from Gate 4, the 14 years of a city's power, the walls of fuel, all of it, due a second time, in full, at the far end. And it is worse than merely double, with a cruelty all its own. Every gram of that braking fuel had to be carried, unburned, across the entire ocean. Dead weight the whole way. Mass that made the launch heavier, the shield thicker, every earlier gate steeper. The bill for stopping is folded inside every previous bill, compounding backward through the whole voyage. And notice how narrow the harbor really is. A solar system sounds vast, but to a ship at interstellar speed, it is a coin on a wide table. From the orbit of Neptune into the Sun is about 4 light hours. At 1/10 of light speed, that whole span is less than 2 days' travel. The blue world itself, the actual destination, The reason for 100 centuries of falling is a target so small that passing within 1,000,000 kilometers of it would count as a bullseye. Everything about arrival happens at once, after nothing happening for 10,000 years. The harbor appears, swells, blazes past, and becomes memory, all inside a span shorter than a working week. Stopping is not a maneuver performed at the end of the voyage. It is a second voyage, aimed backward, that must begin years before the first one ends. Clever minds have spent decades hunting a way to make the destination do the braking. Robert Zubrin and Dana Andrews worked out the magnetic sail, a hoop of superconducting wire, kilometers across, unfurled years before arrival, to drag against the thin wind our sun breathes outward, shedding speed gently across a decade of approach. Robert Forward, ever the boldest, imagined braking by laser light bounced from a mirror, provided someone had thoughtfully sailed ahead, centuries earlier, to build the mirror. Even the famous Bussard ramjet, the engine that was supposed to scoop up the interstellar desert for fuel as it flew, turned out on closer study to work better in reverse. The scoop drags more than it gathers. It makes a fine brake, and a poor engine, the ocean's little joke. Each idea is genuine physics. And each one, read closely, is a beautiful bargain wrapped around the same fine print. Sails the size of cities, approaches that take decades, machinery that must deploy flawlessly after 10,000 years of dark, with no rehearsal, no rescue, and no second pass at the harbor. Stopping, it turns out, is not the end of the journey. It is the whole journey, priced twice. One more gate stays closed, and the sky above you stays quiet. Now we come to the strangest gate of the 8, the one that stands locked even for a ship that succeeds at everything. Because time, in our universe, is not a great clock on a wall that everyone reads together. Albert Einstein showed it in 1905, in the same young patent clerk year that gave us the light speed law, motion bends time. Not as metaphor, as measurement. In October 1971, two American scientists, the physicist Joseph Hafele and the astronomer Richard Keating, bought airline seats for 4 atomic clocks. The tickets reportedly listed the passengers as Mr. Clock and flew them around the world, first eastward, then westward. When they landed and compared their travelers to the reference clocks left at home, the flying clocks disagreed by tens to hundreds of nanoseconds in precisely the directions and amounts relativity had predicted. Whiskers of time, but real and measured and repeatable. Speed up, and your time truly runs slower than the time of everyone you left behind. You carry the proof in your pocket, by the way. Every satellite of the global positioning system wears atomic clocks that run measurably out of step with the clocks down here. A few dozen microseconds every day, the combined bill of their speed and their altitude, and every phone that has ever guided you home has been quietly correcting for Einstein the entire way. Without the correction, your map would drift by kilometers within a single day. Time dilation is not an exotic possibility at the edge of physics. It is built, engineered, and paid for every second of every ordinary afternoon 20,000 kilometers over your head. The universe bends time as routinely as it bends light. Now raise that daily whisker of correction to the scale of a true voyage, years of flight at a meaningful fraction of light speed, and the whisker becomes a canyon, whole decades opening, silently and unarguably, between the ship's calendar and everyone else's. For a starship, this begins as a mercy. Push close enough to light speed, say 99%, never mind for a moment what Gate 4 charges for that, and the clocks aboard run about 7 times slow. A crossing that takes a century by the calendars of the homeworld feels, to the crew, like 14 years. A traveler can board in youth and stand at the destination in vigorous middle age. The ocean, at last, can be survived by a single living heart. But the mercy points only one way, and here the gate swings shut. Nothing slows for the world they left, and nothing slows for the world they are sailing toward. Those keep their own time, spending their centuries at full price. A crew that crosses 1,000 light years, however young they arrive, steps off more than 1,000 years after they departed. 1,000 years of history they were absent from, at both ends of the road at once. The astronomers who first caught the green whisper in our air, gone beyond memory. The committee that weighed the arithmetic of curiosity, and, against all of tonight's gates, voted to sail, gone. Their language drifted, their nation a chapter, their reasons a scholar's puzzle. And the destination has had the same 1,000 years to become something no mission briefing ever imagined. Every starship, whatever it carries, is a message in a bottle, thrown by people who will never learn whether it landed, to be opened by people who never asked for it. And beside all this waits one more small, airless paradox. Our own engineers already know it by name. Any civilization able to attempt a starship is, by definition, still improving. Ships get faster, decade over decade. So the voyage you launch this year may well be overtaken, if progress keeps anything like its pace, somewhere in mid-ocean, by the better, faster ship your grandchildren launch 50 years from now, sailing past their ancestors' pride with a polite dip of the sails, which can make the wisest year to launch feel like it is always next year. And when next year comes, it is next year again, a horizon that walks when you walk. The mathematics of patience quietly eats the mission before it ever leaves the harbor. The 7th gate does not block the road, exactly. It does something gentler and stranger. It makes certain that whoever finally knocks on a far door is a stranger to everyone, including the world that sent them and the world that answers. Arrival, at these scales, is the loneliest kind of success the universe knows how to award. A homecoming with no home on either end of it. There is a last turn to the 7th gate, and it may be the deepest single fact in tonight's whole story. Deeper than the distances, deeper than the price list. For a visit to happen, or even a signal, even one thin hello across the dark, 2 civilizations must exist at the same time. Not in the same eon, loosely speaking. In the same overlapping now, near enough for light to carry between them, while both are still there to care. And the universe is very old, while voices, if our own young one is any guide, may be very brief. Frank Drake saw the shape of this problem in 1961 when he gathered 10 scientists, Carl Sagan, then 26, among them, at a small observatory in Green Bank, West Virginia, for the first conference ever held on interstellar contact. To give the meeting an agenda, Drake wrote a single line of mathematics on the blackboard, a chain of factors multiplying toward one number. How many worlds in our galaxy are speaking right now? It is called the Drake equation, and in the 60 years since, nearly every term in the chain has grown kinder. Most stars have planets. We know that now. Warm, rocky worlds are common. We know that too. Every term has brightened, except the last one, the lifetime term. Written simply as L, how long does a speaking world keep speaking? On this, the universe has given us exactly one measurement. Ourselves, a little over a century of radio and counting, and no promise whatsoever about the rest. And L, more than any other term, may decide the whole answer, and it is the term we know least. If worlds typically stay loud for 10,000 years before falling silent, for any reason at all, caution, boredom, transformation, misfortune, or simply switching, as we already are, to quieter tools, then across the galaxy's 13 billion years, voices flare and fade like fireflies over a summer field at dusk. Even if hundreds of thousands of worlds have spoken across all of time, the field is so wide and the flashes so brief that almost never do two glow in the same corner in the same hour. Run the gentle version of the arithmetic and feel what L does. Be generous everywhere else. Let the galaxy have raised 1,000,000 worlds that ever learn to speak. If each stays loud for 10,000 years, then across 13 billion years of galactic history, any given lantern is lit for less than 1 moment in 1,000,000. Ask for 2 particular lanterns to burn at once, near enough to matter, and the small chances multiply against you. The summer field goes dark and patient for ages between flashes. Shrink L to 1,000 years, one comfortable span of civilization, and the field grows darker still. This is why the final term of Drake's blackboard line may matter more than all the others put together. May. On that, the blackboard is still blank. The question was never how many worlds ever speak. It is how long each one keeps its porch light burning, and of that, the universe has shown us exactly one porch light, our own, barely a century lit. Ours may burn very long. No law of physics forbids a patient world. The astronomer Iosif Shklovsky, who wrote the first great book on this subject with Sagan in 1966, 2 authors who never once met in person, their manuscript crossing between Moscow and Cambridge by mail, understood exactly what the arithmetic implied. The problem is not that neighbors are absent. It is that neighbors are separated by silence in time as well as space. And even when 2 lanterns do overlap, listen to what conversation would mean. Suppose a speaking world sits just 100 light years away, by galactic measure, practically leaning on our fence. A question sent tonight arrives in 100 years. The answer returns in 200. A single exchange, one hello back, outlives every single person who began it. What remains is not conversation at all. It is closer to archaeology. Each side studying the other's century-old light, the way we study letters found in an attic, tender, luminous, and unanswerable. Two lanterns, lit in one long night, a wide field apart, each flickering out before the other's glow can reach it. Neither lantern failed. The night is simply that large. And every world that ever counts its neighbors must count them across both maps at once, the map of distance and the quieter, stricter map of time. One more gate stays closed, and the sky above you stays quiet. And still, let us grant everything, every page of it, the finding against the glare, the choosing against the catalog, the ocean, the price list, the desert, the double bill of breaking, the centuries of drift, all of it, somehow, paid in full. A visitor's craft, machine, most likely, if the arithmetic of Gate 2 held, slides at last into our solar system on a quiet, sensible orbit, its 1,000-year maps unrolled, its instruments waking one by one. One doorway remains, and it is the only gate of the 8 built from biology instead of physics, the doorway of actually touching a living world. By every rule of planetary protection we know, it must be treated as dangerous in both directions at once. Every world's life is a chemistry that has been arguing with itself for billions of years, testing, defending, adapting, keeping ancient scores no outsider can read. Two such chemistries have never met. Our own history offers one soft, sobering rhyme for what happens when even close cousins reunite. 5 centuries ago, when long-separated branches of the human family reconnected across the Atlantic, the invisible passengers did more harm than any fleet ever did. Between wholly separate biochemistries, no one can say whether harm is even possible, and that uncertainty is precisely the point. You plan for the worst the universe might allow, and the caution must run deeper still. Any civilization wise enough to have crossed the ocean of stars is wise enough to know the oldest rule of visiting. You do not walk into a living garden in muddy boots. You send something clean. A sealed instrument. A sterile eye that looks and records and touches nothing. Which is one more reason, perhaps the final, quietest one, that the rational visitor to any living world is a small, careful machine, keeping a respectful distance. If the universe has good manners, they are enforced by microbiology. And notice, the universe has already sent us rehearsals. In October 2017, a telescope in Hawaii caught something crossing our solar system on an unbound path, too fast, too straight, owing nothing to our sun. It was named Oumuamua, a Hawaiian word meaning, roughly, a messenger from afar, arriving first. It was the first confirmed object from another star ever seen in our system, and we spotted it only after it had already rounded the sun and was leaving, tumbling and silent, too quickly for any spacecraft to chase. 2 years later came a second traveler, the comet Borisov, found by an amateur astronomer in Crimea with a homemade telescope. Both, all evidence says, were natural, wandering stones, shed by far systems, not sent things. But between them, they proved the doors do open, matter does drift from star to star, and does pass through our harbor. We simply were not watching well until it was nearly gone. The Vera Rubin Observatory, opening its great survey eye in Chile this decade, is forecast, if today's models hold, to catch such interstellar wanderers far more often, perhaps several in a year. The visitors we will actually log, in all likelihood, are stones. And those two wanderers carried one more quiet lesson between them. Each was a piece of another solar system, actual matter, born around an actual other star, passing close enough for our telescopes to weigh and wonder at. The galaxy, it turns out, has always exchanged such gifts. Slow stones have drifted between the stars since before our sun was lit, needing no engines, no budgets, and no committees, because stones do not mind the fare, and stones are never in a hurry. On timescales of millions of years, the doors between the stars stand slightly, perpetually ajar, for anything patient enough to be mineral. It is only the living, with their heartbeats and their memories and their deadlines, whom the ocean so effectively refuses. So let the ledger of the whole night be read out, honestly, gate by gate, because you have earned the summary, and it is short. Physics forbids, absolutely, permanently, for every being in every galaxy, exactly one thing: carrying mass to the speed of light. That door has no price, because it has no hinge. Every other gate of the 8 stands merely priced, energies that swallow the output of nations for years, journeys that outlast lives, institutions, and perhaps whole civilizations, machines that must not blink for 100 centuries, a bill that silently doubles at the far shore, and a calendar that turns every arrival into a stranger's homecoming. Not one line of the ledger says cannot. Every line says, this is the cost. And that is what the word in tonight's title honestly means. Impossible, not as law, but as ledger. Effectively impossible. Impossible the way it is impossible to drink the ocean. No rule against it, and no one, anywhere, ever will. So, one last question before the walls of home, and it is the question this whole story has been carrying. If the galaxy really is full of worlds standing behind gates like these, what should it sound like from where you are lying? It should sound like this. Exactly like this. Because we have listened. We have been listening now for a human lifetime. In the spring of 1960, a young Frank Drake, the same Drake of the blackboard equation, pointed a radio dish in Green Bank, West Virginia, at 2 nearby sun-like stars, Tau Ceti and Epsilon Eridani, and named the effort Project Ozma, after the princess of a faraway fairy tale land. Humanity has been leaning toward the loudspeaker ever since. Jill Tarter, the astronomer whose life inspired the heroine of the film Contact, spent 4 full decades turning that lean into a rigorous science, survey after survey, dish after dish. And in all those years, across millions of channels, and thousands of stars, exactly one sound has ever made the whole room go still. On a summer night in 1977, at the Big Ear Radio Telescope in Ohio, a signal rolled through, 30 times louder than the background, narrow as a laser line, shaped exactly the way an artificial beacon should be shaped. The astronomer Jerry Eman, reviewing the printout days later, circled the 6 characters of its intensity code with a red pen and wrote one word in the margin: "Wow." It lasted 72 seconds, the full time the telescope's fixed gaze took to sweep that patch of sky. It has never been heard again. The Big Ear itself is gone now, dismantled in 1998 to make room for a golf course, which may be the most quietly human ending any observatory ever had. 10,000 follow-up hours have hung on that spot of heaven. The night has kept its counsel, and the quiet runs far deeper than radio. Astronomers have swept the galaxy in infrared, hunting the one thing truly vast engineering could never hide: waste heat, the warm exhaust of any civilization rebuilding its stars, the glow Freeman Dyson taught us to look for around a star wrapped in machinery. The great infrared surveys have checked hundreds of millions of stars and entire neighboring galaxies besides. No such glow has yet shown itself, no waste heat of the kind we know how to recognize. Everywhere we have pointed anything, radio, optical, infrared, the universe's books, as far as we can read them, balance, nature in, nature out. Be careful, though, with what the silence does not say. It does not say the galaxy is dead. 60 years of listening against 100,000 light-year haystack is 1 teaspoon dipped once into a sea. It does not say we are alone. Tonight's 8 gates leave generous room for a galaxy that holds both company and quiet at once. And it certainly does not say that something is wrong. Every previous generation of our species looked up at this same silence and filled it with omens, with gods, with judgments, with signs. Ours is the first generation that can look up and read it correctly, as the natural hum of a universe in which distance is real, energy is honest, and every fire stays home in its own hearth. The silence is a measurement, not a verdict, and measurements, unlike omens, improve with every year we keep listening. For decades, thinkers have treated that silence as a riddle, demanding ever stranger answers. But you have walked the 8 gates now, and you can hear it differently. A galaxy in which every voyage must be found, and chosen, and crossed, and paid for, and survived, and braked, and timed, and touched. A galaxy where all 8 doors must open in sequence, and every one carries a price no world can sensibly pay. Such a galaxy could be full of life, and still be almost empty of visits. Its worlds would bloom, and think, and look up, each behind its own 8 doors. And their voices? Remember that Gate 1 swings both ways. Signals thin with every light year they cross, and lanterns rarely overlap in time. Between the gates that stop the ships and the distances that starve the signals, each of those worlds might well hear very much what we hear: nothing, which is not nothing at all. It is the sound of physics holding door after patient door, one honest reading of the great quiet and the one reading a person can actually sit down and calculate the most ordinary sound in the universe. It is the sound your own ceiling makes on a windless night. The silence over your roof is not a held breath. It is a settled house. One more gate stays closed, and the sky above you stays quiet. And now, before sleep, let us do the one thing our visitor never could. Let us turn around and walk back through all 8 gates from the inside. Because from the inside, and this is the secret the whole night has been keeping for you, they are not gates at all. The same distances that price every voyage beyond sensible reach are the walls that have kept every storm in the universe far from your window for 4 billion years. The same energy bill that grounds every armada is the bill that grounds anything unkind the dark could ever think to send. The centuries that swallow every voyage are the same centuries that leave every world alone, unhurried, to grow up slowly in its own patient light. Even the glare that hides our little planet is our own hearthlight, pulled close. The universe, it turns out, is not a dangerous ocean pressing at your door. It is the thickest, oldest, most patient set of walls any home has ever had, and they were finished long before you were born. You are not locked out of anything tonight. You are tucked in. And the strangest gift of the whole story is the one we walk past every day without seeing, how close everything that matters actually is. The moon, the farthest shore any human being has ever stood on, the whole of Neil Armstrong's giant leap, sits 1¼ light seconds from your pillow. Light, which needs 4 years to reach the nearest star, crosses from the moon to you in the time of a single heartbeat. And every voice you have ever loved, every hand you have ever held, every lit window of your whole life, all of it lives within a single light second of where you are lying right now. On the map we have drawn tonight, a map measured in oceans without shores, in price lists without mercy, in 800,000 years of counting, the entire human world is one warm point. This one, with everyone in it. Hold that thought against the whole journey we have made tonight. 8 gates, and every one of them we measured in impossibilities, years of counting, cities of power, centuries of falling. And yet every good thing that has ever happened to you happened inside 1 light second. Every meal, every friendship, every song, every laugh, every reunion, at every arrival's gate, all of it, always, within a single heartbeat of light. The universe, for all its size, put its treasures in the smallest room of the house. People sometimes call ours the age of cosmic loneliness. Lying here, at the end of the 8 gates, you can hear how wrong the name is. Nothing that loves you is far away. The far things are only the walls. Do you remember the beam of light we sent out at the beginning of the night? The little shine that slipped from your window when the story began? Look how far it has gotten. 2 full hours of flying at the fastest speed the universe allows, and it is still in the sun's front yard, out among the pale giant planets, not yet past the neighborhood where Uranus keeps its slow blue orbit, with 4 years and 3 months of dark road still ahead of it before it passes even the nearest star. 2 hours at the cosmic speed limit, and it has not left the driveway. Even our Voyagers, after 50 years of falling, are not yet one full light day out, past the sun's breath at last, adrift in the space between stars, yet still held in its gravitational hand, still phoning home on 20 watts, like a porch light seen across a wide field. That is the true thickness of the walls around this house. So let the visitor rest, wherever they are. Behind their own 8 doors, under their own quiet ceiling, in the deep safety of their own walls, wondering, perhaps, this very night, about us. 2 settled houses on one long street, both porch lights on, both warm, neither ever needing to knock. If tonight's slow journey helped you drift, you can simply leave the video playing. The soft dark that follows is part of the night, and if you would like more nights like this one, a quiet subscribe is always enough. Nothing else is asked of you. The house is old. The doors are shut, and everyone you love is one light second away. Every gate out there stays closed, and the sky above you stays quiet and yours. Good night.